Hello, everybody. Welcome to session 2 of chapter 4. The objectives of this session are to differentiate gravity from gravitation, to list effects of gravity, to define and factors affecting acceleration due to gravity, to differentiate small g from capital G, to explain feather and coin experiment. Now let's start with the topic gravity. It is also called force of gravity. So you might have heard about gravity. So from this picture also you can get some idea about gravity. So every object that is on the earth pulls every object towards its center. And the force by which earth pulls the body towards its center is called gravity. So the force by which earth pulls the body towards its center is known as gravity. And the space, like this is earth, and there is a certain space around the earth where you can experience gravity. You cannot experience the gravity from any distance. Suppose you are very far from the earth, then you will not get the effect of gravity of the earth. But there is a certain space around the earth where you can experience the gravity, and that space is called gravitational field of earth. And because of gravity, we have weight. So you can see every object is pulled by earth towards its center, and because of that gravity, every object has weight on the earth. But if the body is taken to space, it will not have weight. Why? Because there is no gravity. Now formula for gravity and weight is same. So we have already derived this formula. So force and weight, as weight is also force. Here you can see in the definition, the force by which earth pulls the body towards its center is known as gravity. And gravity is a force. That's why formula in place of F, you can write even W. W means weight. And you can use same formula to find the weight. And gravity depends on mass of heavenly body. And you know that the moon has less mass than the earth. That's why the gravity of moon is also less. So how much less? 1/6 of gravity of earth, means it is 6 times less than gravity of earth. And because of that, if a man can jump 0.5 meter on earth, he can jump 6 times on the moon. That means 6 times into 0.5 means 3 meter on the moon. Similarly, if a man can lift 10 kg here, then on the moon he can lift 6 times more. That means 6 into 10 means 60 kg on the moon. Now, effects of gravity. So one people can stand everywhere on the earth surface. So you can see in the previous diagram here, see, because of gravity we are able to stand on the earth surface. The next effect is acceleration due to gravity is also caused by gravity. This term we'll be discussing later, but because of the gravity, acceleration due to gravity is caused. When a body is thrown vertically upward, it falls down. So see here, this is a symbolic picture of apple. So if apple is thrown upward, then this apple will be falling down. The reason is gravity. And whatever the construction that we have done on the earth, like buildings, bridges, uh, so many structures that we have made on the earth, that is all possible due to the gravity. Now, difference between gravity and gravitation. So gravity, just now we discussed, it is the force by which earth pulls the body towards its center, whereas gravitation is the force of attraction between any two bodies. Remember, in this, when we are defining gravitation, I told you gravitation means it is the force of attraction between any two bodies. That two bodies can be huge bodies, and that two bodies can be very tiny. Gravity, it is not universal force. The reason is that gravity is not exerted by any kind of body. It is always exerted by the huge. It is not universal force. As I told you, gravity is exerted only by a body having huge mass. Like Earth can have a gravity, Sun can have a gravity, but a stone cannot exert gravity because it has very small mass. Whereas gravitation is universal force. The reason why we call it universal force is that it is produced between any kind of two bodies. The two bodies can be huge bodies and the two bodies can be very tiny. That's why gravitation is called universal force, whereas gravity is not universal force. And just before we discuss, because of gravity, weight of the body is caused. So gravity causes weight of body, but gravitation, it does not cause weight of body. And gravity, it is experienced when body is in gravitational field of Earth. So just now we discussed gravitational field means the space around the Earth where we can experience gravity. But gravitation, it can be experienced between any two body in the universe. Now, acceleration due to gravity. So in class 9, you have discussed already. Acceleration means the rate of change of velocity per unit time. So if a body moves, then it will always change its velocity, and because of change in velocity, acceleration is produced. So here also, if a body is dropped from the top of tower, then this body will change the velocity. Means as it comes close and close to the earth, the velocity will be more. So this change in velocity because of gravity is called acceleration due to gravity. So definition is the acceleration produced in a freely falling body due to gravity of Earth is known as acceleration due to gravity. And it is represented by small g, and its value on Earth is 9.8 meter per square second. So when a body is dropped from the top of building, anybody, when it is dropped from the top of building, or if it is dropped from anywhere, then its value will be 9.8 meter per square second. Its value on different heavenly body is different. Like the value of acceleration due to gravity on moon is 1.6 meter per square second. Similarly, value of acceleration due to gravity on Jupiter is 25 meter per square second. So, it has a meaning. Like question may be asked in exam, value of acceleration due to gravity on Earth is 9.8 meter per square second. What does it mean? So it means, when a body falls freely. So here you can see body is falling freely under the action of gravity towards the center. That time, what will happen? If it is an Earth, it changes its velocity by 9.8 meter per second in every 1 second. So here you can see. So at the very beginning, the velocity will be zero, but when it is dropped, then in first second, the velocity will become 9.8 meter per second. In second, 19.6 meter per second. In third second, 29.4 meter per second. And in the fourth second, 39.2 meter per second. So here, if we subtract from 9.8 to 0, the change in velocity is 9.8 meter per second. Here, if you subtract 19.6 with 9.8, then your change in velocity is also 9.8 here. Similarly, if you subtract from 29.4 to 19.6, here also it will be 9.8 meter per second. Similarly, if we subtract from 39.2 to 29.4, here also the change in velocity comes 9.8 meter per second. That means on the Earth, in every 1 second, the velocity is changing by 9.8 meter per second. So here also 9.8 meter per second, here also 9.8, here also 9.8, here also 9.8 meter per second. So since the velocity is changing by 9.8 meter per second in every 1 second, the value of acceleration due to gravity is called 9.8 meter per square second. In 1950, Italian scientist Galileo, he conducted one experiment on Leaning Tower of Pisa by dropping two bodies of different mass. And what he found that both bodies, they reached the ground at the same time. And question may come, why they reach the ground at the same time? Because they both drop with the same acceleration due to gravity, that is 9.8 meter per square second. So what is the conclusion of this experiment is that value of acceleration due to gravity is independent to mass of body. It means that it doesn't care what mass the body has, every body, whenever it is dropped from any height, that body will have acceleration due to gravity 9.8 meter per square second on the earth. So conclusion is value of G is independent to mass of body. So astronauts who went by Apollo 12, what they did, they dropped stone and feather on the moon, and what they found is they found both reached the ground at the same time. The reason is because value of G is independent to mass of body even on the moon. Now, difference between capital G and small g. So, small g, as you know, it is the acceleration produced in a freely falling body due to gravity, whereas capital G is it is the force of gravitation between two bodies of unit mass separated by unit distance. And its value on Earth is 9.8 meter per square second, where its value is 6.67 into 10 to the power minus 11 Newton meter square per square kg. And its value is variable, like Earth has 9.8, Moon has 1.6, and Jupiter has 25 meter per square second, whereas value of capital G is constant throughout the universe. And it is vector quantity. The reason is it has magnitude plus direction. The direction is always towards the center of Earth. But capital G has only magnitude but no direction. That's why it is scalar quantity. Now, feather and coin experiment. So let's discuss here. So this is a glass tube of 1 meter long, and what we did is we put coin and feather. And when you invert it, then what you will see is that coin will reach the bottom earlier than the feather. The reason is feather will experience air resistance. But in second step, if you create the vacuum, and if you repeat the same experiment, what you will see that both coin and feather reach the ground at the same time. So what is the conclusion? Once again, value of G is independent to mass of body. Either coin or feather, no matter what mass they have, they will reach the ground at the same time. But in real life, since there is air, so there will be air resistance, and because of air resistance, feather will reach the ground later than the coin. But if there is no air resistance, then the acceleration due to gravity is independent to mass of body, and because of that, the both coin and feather will reach the ground at the same time. So in vacuum, metallic ball and feather reach the ground at the same time if dropped from the same height. Why? Because G is independent to mass of body and there is no air resistance. Now proving formula. So capital small g is inversely proportional to square of radius of Earth. So this is the figure. So this big circle represents Earth and this small circle represents mass of the body, small m, and this is the Earth, capital M, and this is radius of Earth. And there are two bodies, so force of gravitation is F, and because of gravity of Earth, acceleration due to gravity is produced. So that's the language written. Suppose a body of mass m is placed on the surface of Earth having capital M and radius r, and the force of gravitation between them is F, and acceleration due to gravity is small g. And according to Newton's law of gravitation, so if you remember, we proved this formula based on Newton's law of gravitation. So if you apply this formula over here, then F equal to capital G is same, and M1, M2 means mass of two bodies, so capital M is small m by distance here. Distance is from the center, so this is the radius, and if you extend it slightly, it will not make any difference, so R is square. And also in Newton's second law of motion in class 9, you have already learned F equal to ma. So A means acceleration, so here acceleration is G. Now from equation 1 and 2, so in equation 1, in place of F, we can put this mg. So if we put this mg, then mg equal to capital G, capital M, small m by r square. And this is small in both side, we can cancel. So remaining is small g equal to capital G m, and this m is already cancelled, so by r square. And here, this is equal to, and capital G is also constant, and m means mass of Earth, it is also constant. So equal to and constant means sign of proportion. So here nothing left, so 1 by r square. So in this way, this relation is proved. Value of G on Earth. So value of g, as we have just proved this formula. So in this formula, while proving this formula, if you see this expression, so value of g depends on mass of heavenly body or earth, let's say, and this is the radius of heavenly body. It doesn't depend upon capital G because it is always constant. So value of G depends on mass of heavenly body and its radius, and height means how much high it will go, and depth means how much deep it comes inside, and even rotation of heavenly body too. And our earth is oval in shape, and because of that the radius is different in different place of the earth. So you can see this is the polar region. So in polar region radius is less, whereas in equator it is bulging out, so equator radius is more. And because of this relation, it is inverse means opposite relation. So if radius is more, then g will be less, and if the radius is less, g will be more. So means at pole radius is less, so if the radius is less, g will be more, whereas in equator radius is more, so g will be less. Value of g at pole is 9.83 meter per square second, whereas value of g at equator is 9.78 meter per second. So here you can see at pole the value of g is more. What is the reason? Because pole has less radius, whereas value of g at equator is less. Why less? Because radius is more here. Hence, if we drop the body once at pole and equator from the same height, what you'll find, since value of g is more at pole, that's why at pole the body will reach the ground faster than the equator. So here is a question: why acceleration due to gravity of Jupiter is 2.5 times more than Earth, though radius and mass of Jupiter are 11 times and 319 times respectively than that of Earth? So here you can see the radius of Jupiter is just 11 times more than Earth, and mass is 319 times more than the Earth. So despite having more radius and mass, the value of acceleration due to gravity is just 2.5 times more than Earth. Why? This is the question. So here you see the relation. Uh, Here the radius has increased by 11 times. So when radius increases, then what will happen? Acceleration due to gravity will decrease. And because of this reason, though radius and mass of Jupiter really high, but it will not make that much significant difference in value of acceleration due to gravity. So answer is, though radius and mass of Jupiter are 11 times and 319 times respectively than that of Earth, acceleration due to gravity of Jupiter is just 2.5 times more than Earth. Because with increasing radius, so here you can see radius is increased by 11 times. Because of increasing radius, what will happen? Value of acceleration due to gravity decreases. Because of that, just it has increased by 2.5 times. Now some formula that you need to always keep in your mind. This formula we proved, and your force and weight is same. So because of that, the formula is same. And even second formula, we proved force equal to even mg we can write, and even weight also mg. So it depends on condition. If mass of heavenly body, radius of heavenly body are given, then you can apply this formula to find the weight. But if simply mass of body and acceleration due to gravity is given, you can apply this formula to find the weight. And small g equal to, while proving the relation, we got this expression capital G capital M by R square. So this formula will apply when it is on the surface. When you are supposed to calculate value of g on surface, apply this formula. But if you have to calculate value of g on height over here, then apply this formula. Here see, it is not new formula, just we have converted this formula into this formula. So here r means radius, also we can say it is distance also. So r, and if body is here, then r plus h. So that's why in place of r we have written r plus h whole square. And if you find the ratio of g dash by g, then you will get this expression, and this also can be applied as a formula. So here is some example of numericals. So here you can see mass and radius of moon are this much. And the question is asking what is the acceleration due to gravity on surface of moon and 10 kilometer above its surface, means on surface and 10 kilometer above. And also question is asking what is the weight of an object on surface here and at that height if the mass of that body is 200 kg. So these are the given mass of moon, this one, radius of moon, and height given 10 kilometers, so we have to convert into meter, multiply by 1000, and mass of object is 200 kg. Mass of object we always symbolize by small m. And questions are asking on surface, at height, and weight also is asked on surface and height. So let's apply formula. So first it is asked on surface. On surface formula G is capital Gm by r square. So we are placing the values. So when you multiply these numbers, you'll get 4.8 into 10 to the power 12 by, if you do square of this, you'll get 2.89 into 10 to the power 12. So the result is 1.66 meter per square second. So on surface, the value of G is 1.66. But on height, how much height? 10 kilometer above. So you will apply this formula. So keep those values, do the calculation. So what you'll find is 1.64 meter per square second. And weight is asked on surface. So you will apply this G. So G value is 1.66. So if you multiply, it comes 332 Newton. But on height, G dash, will apply this value. So 1.64. So that's why you got the result 328 Newton. So conclusion we have written here. As a good, we have now another example of numerical. So mass and radius of Earth are given this much value. What is the acceleration due to gravity at 500 kilometer above its surface over here? If acceleration due to gravity on surface is given 9.8 meter per square second. And similarly, there is another question. What is the weight of a person at that height having mass 80 kg? So what is the difference here? In previous case, the value of G you have calculated on surface and on height. But here you are given value of G on surface, and with that you are asked to calculate value of G on certain height. So let's go to solution. So mass of Earth, this one, radius of Earth 6400 kilometers, so you have to convert into meter, and height is given 500 kilometers, so 500 kilometer again convert into meter, and mass of person is given 80 kg, so mass of person is small m. And what are the question asked? Like you are also given acceleration due to gravity on surface of Earth is 9.8 meter per square second. Now you have to calculate acceleration due to gravity at this height and weight of person on that height. So if the value of G is given on surface, then we can apply this formula. Now let's keep the values. So capital G dash, you are asked by small g values 9.8 equal to r radius 6.4 into 10 to the power 6. So this r is square by bracket, and r is 6.4 into 10 to the power 6 plus h is 5 into 10 to the power 5 whole square. Now capital G by 9.8. Now if we do the calculation, if you do the square of this, you will get this result by, if you do the calculation here, you'll find 4.67 into 10 to the power 13. So after doing the calculation, you'll get the result 8.42 meter per square second. That means the value of acceleration due to gravity 500 kilometer above is 8.42. On surface it was 9.8. On surface it was 9.8, and on that height you will find 8.42. It is less. And now next question is asked what is the weight at that height. So you will apply the formula weight equal to mg dash. Why? Because you are asked the weight at height, so at height means g dash you are going to apply. So m is 80 kg and g dash is here is 8.42. So result is 673.64 Newton. So hence acceleration due to gravity at height is 8.42 meter per square second, and weight of a person at height is 673.64 Newton. So with this, we want to wrap up session 2. Thank you.